Okay, so welcome to 2.3, which is measures of the location of data. So I am going to go through this. Take two. So here we go. So data, we're talking about percentiles and quartiles today. So first of all, what are percentiles and quartiles? So percentiles, they take the data that's in order and they divide it into hundreds. So if you think of the word percent, that means per hundred, right? If you take so similarly for quartile, you can think of a quarter, which is like a fourth, right? Quartiles divide the data into quarters, so into 4 sections. Okay, so if you want to, so to think about percentile, if you score them in the 90th percentile of an exam, it doesn't mean that you necessarily received 90% on the test. It means that 90% of the test scores are either the same or less than your score, and 10% are either the same or greater than yours. Okay, so where would we be without formulas? So the formulas to find percentile and quartile are here. Okay, so find the position of the percentile that we're looking for. So if you want to find the 50th percentile, you would use obviously the over 100, right? 50 would be your K, and then N is your sample size, and then I represents not the percentile or quartile, but merely the position in the list, the position of the percentile, the ith place. Okay, so this is the formula for percentile, the K over 100, and the K over 4 is quartile. Okay, let's keep going. So let's do an example. So here we have 29 ages for Academy Award winning Best Actors in order from smallest to largest. Okay, so we have here, so they're already in order 18 and then 77. So they ask us to find the 70th and then the 83rd percentile. So the 70th, we take the equation, right, because we're talking about percentile, so we're going to use the one with the 100 in it. And we plug in 70 for K, because that's the percentile we're looking for. And then, what is our N? Our N is 29. So here we plug in 29. So then we have 70 over 100 times the quantity 29 plus 1. And then the total is 21. So I is equal to 21. So what that means, we have here that the ith position, so 21 is where the percentile will be located. So you counting from here, so you go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, da da da, and the 21st one is here, 64. So we would say that the 70th percentile is 64 years. Okay, so now let's do another one. What if they want to tell you, what if they're asking us for the 83rd percentile? Okay, well in this case, K is 83, so we plug that in. N is still 29 because that's our sample size. That's the number of numbers. N is pretty much throughout the whole course. N will stand for sample size. Okay, so we plug that in. We get a decimal. So then you're like, okay, what is this decimal here? Well, it's not an integer, so what that means is we're going to look for the number that's between 24 and 25. So this is the 21st number, this is 22nd, this is 23rd, this is the 24th number, and 72 is the 25th number. So since the I is in between 24 and 25, we need to take the average of these two to get our percentile. So we take the average of 71 and 72, and that becomes 71.5. So you would say the 83rd percentile is 71.5 years. Okay? So just to restate this again. Okay, when I plug in, I'm looking for the 83rd percentile. Okay, fine. I plug in 83 for a K, because that's the percentile. N is 29. I get a decimal. And remember that I is the position. So basically we think, okay, 24.9 is between 71 and 72, which are the 24th and the 25th number in the order from smallest to largest. And we take the average, and that's what we give as our solution. 83rd percentile is 71.5 years. All right. Okay, so next we have here, for the following 13 real estate prices, we calculate the inner quartile range and determine if any prices are potential outliers. Prices are in dollars. So first of all, inner quartile range is equivalent to Q, sorry, this is going to be terrible, but this is Q3 minus, oh my gosh, I'm sorry, Q1, okay? So we need to figure out third quartile and first quartile. So here we go. So QR is the distance between Q1 and Q3, so it's the difference. So it's Q3, sorry, this is supposed to be a minus, I'll put it up here, minus Q1, okay? So, so basically we take this data, here's our formula for quartiles, right? We're gonna find Q1, so K is equal to 1, and N is the sample size, so that's 13. So we just plug it in. We get 1/4 of 14, which is 3.5. Okay. So the third and fourth numbers are 1, 2, 3, 4. We take the average in between these two. Okay. We take the average of these two, and that's our Q1. Okay. So if you take the average of these two, you get 308,750. That's Q1. Now let's do a similar calculation to find Q3. Okay, so Q3 is just K is equal to 3, N is still 13. We plug that in, we get 10.5. So if we keep counting, we get 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 10.5 is in between these two, so we need to take the average of these two values. So we get 639,000 plus 659,000 divided by 2, that's the average. So Q3 is 649,000, okay? So let's go ahead and continue. Now, since IQR is the difference, right? It's Q3, so here it is, Q3 minus Q1. IQR is inner quartile range, and we're gonna go over that again, but all you need to know is the difference between Q3 and Q1, and that's 343,250. So, you know, there's all our work. Now, to find outliers, we need to understand that there's a way to calculate an outlier. What we do is we take the IQR, multiply it by 1.5, and we get this amount. Then we subtract that amount from Q1 and we add it to Q3. So the idea is that you're kind of like, okay, here's your data. You know, you have Q1, Q2, the median, Q3, and then the maximum value, which is Q4, right? But we usually just say Q max. So if you did a box plot, this is where the concentration of your data would go. Sorry, oh man, that's terrible. But you know, if we did a box plot, it would kind of be like right here. I'm sorry, I'm gonna work on this. Okay, so if I did 1.5 times this and subtracted it, it would be over here somewhere. It's like another fence. And over here maybe. If you have a value that occurs outside this region, it's considered an outlier, okay? So here, our higher fence would be 1,159,375 because I took Q3 and I added 1.5 times the interquartile range. So I add these together. Now look at this value. This value here is 5,500,000. That's greater than our fence or, you know, like our upper bound here. So this value is a potential outlier. Okay. Okie dokie. So now, what if we wanted to find out what the percentile of a specific value was? Okay. What if we wanted to work backwards? So before this point, we were given K, we needed to find I, you know, all of that. So what if we were given the value and its position, you know, like its position, and then we want to go work back and tell me, well, it's the 23rd percentile, oh, this is like at the 25th percent or whatever, you know. So here's what you need to do, okay? So if you have the data, you go from smallest to largest. This is our formula, okay? It's basically going to give us the K. So X is going to be the number of data values counting from the bottom up to but not including the data value for which you want to find the percentile. So it's not exactly I, but it's close. It's actually I minus 1. If you understand that I is the position of the data value, X will equal I minus 1. Okay, so it's all the numbers up to below, the number of data values before that one that we care about. And then Y is how many times does it repeat? So number of data values equal to the data value for which you want to find the percentile. In other words, does it repeat? If so, how many times? Okay, that how many times is our Y. And then N, of course, represents the total number of data. There's nothing new there. So let's go back to this equation, this situation. Same situation, we have the same data set, the 29 ages. And now we want to find the percentile for 58. Okay, so 58 is over here. Okay, and we say here, okay, counting from the bottom, there's how many data values. So we count from the bottom, you know, going all the way up to here. Okay, so there is 18 data values because 58 is in the 19th place. So all of these, if I count all these up, I get 18. So X is 18. Now, how many times does 58 occur in here? Well, it only occurs once. There's no repetition, so my Y is 1. Then I plug it into this formula. I get 18 plus 0.5 times 1 all over 29, which is N, sample size, times 100, and that gives us the percentile is 63.8, but it's very close to 64, so we will say 64th percentile. We would say 58 is the 64th percentile. Okay, now let's do the percentile for data value number 25. Okay, here it is. Boom, 25. Okay, so what is X, right? How many numbers are there from the beginning of the list to right before 25? 1, 2, 3. So my X is 3. Okay, does 25 repeat? And if so, how many times? No, it does not. It only occurs once. So Y is 1. Then we plug those in. Okay, so 3 plus 0.5 times 1 all over N, which is 29. Okay, and we put that in the calculator and multiply it by 100, and you get 12.07, which is close to 12. So we say 25 is the 12th percentile. Okay, that means that at 25, okay, 12% of all of the entire of all the data is less than 25. Okay. All right. So let's continue. This one talks about interpretation. So median is the 50th percentile, or you could think of it as the second quartile. Okay. A percentile may be considered good or bad depending on its context. Okay. It really just depends. So sometimes a low percentile will be good, and sometimes a high percentile might be considered quote unquote good. In some situations, there's no value judgment. So let's say, for example, here we have a timed math test, and the first quartile for time it took to finish the exam was 35 minutes. So let's consider this first quartile. 25% of the students finished the exam in 35 minutes or less, right? So that means that the first quartile is 25%, or 1/4 of everybody. Okay, so since it's that's the percentile, 25% is the same as saying first quartile, then that means 25% of the students finish the exam in, and then the data value, 35 minutes or less. Okay, so what does that mean for the rest of the data? That means, well, 75%, the remaining amount of students, finish the exam in 35 minutes or more. Okay, and then you have here, in this case, a low percentile could be considered good because finishing more quickly is usually desirable, unless, you know, because if you take too long, you might not be able to finish. All right, so another super fun example. If you're at a community college, it was found that the 30th percentile of credit units that students enrolled for is 7 units. Let's interpret the 30th percentile in the context of the situation. So what that means is that 30% of students are enrolled in 7 or fewer credit units, okay? And 70% of students are enrolled in 7 or more credit units. So in this example, like, there's no good or bad, because, so why isn't there a good or bad? who knows why someone is taking courses at community college? You know, we don't know if it's just, there's so many different reasons and needs. So it really just depends. The course load depends on their needs. It doesn't have to do anything like, oh, they're good or they're bad. No, 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 because we're all different. Okay, so that is it for section 2.3. And this is your super fun homework, and I will see you guys on the next video.